Hello, my dear student. Welcome. Join the physics classes. Now, in this session, we discuss about work done in moving a body down an inclined plane. The first thing we discuss about the work done in moving a body down an inclined plane. As we see, it is very clear from the figure. At the inclination, we put a body. The weight of the body is divided into two parts. The mg cos theta is balanced by the reaction force R, and mg sin theta is balanced by the applied force. Okay, the weight mg is divided into two parts. The weight mg sin theta is balanced by the applied force, and the mg cos theta is balanced by the reaction force R. Now the Fk is the force of friction, the kinetic friction of force. The R is equal to mg cos theta. The force of friction Fk acts up the inclined plane. The force of friction Fk acts of the inclined plane. So the applied force is, now the applied force is P is equal to Fk minus mg sin theta. As we know that mu is equal to F by R, as we know that mu barabar F by R. So at the place of Fk we put mu kr minus mg sin theta. At the place of Fk we put mu kr minus mg sin theta. As P is equal to mu k, at the place of R we put mg cos theta. So the equation is mu k mg cos theta minus mg sin theta. As mg is common, P is equal to mu k mg cos theta minus mg sin theta. P is equal to mu k mg cos theta minus mg sin theta. As mg is common, so if mg is common, then mu k cos theta minus sin theta, or W barabar P into S, force into distance. So at the place of force we put mg mu k cos theta minus sin theta into S. It is the required relation. W is equal to mg into, inside the bracket, mu k cos theta minus sin theta, and mg and S is common thing. So inside the bracket we put mu k, so in the subscript we put k. To mu k cos theta minus sin theta, it is the required relation for work done to moving a body down an inclined plane. Now the second one is acceleration of a body sliding down. The figure is similar. The angle is theta. If Fk is the kinetic friction, then the net force is, if Fk is the kinetic friction, then the net force is F is equal to mg sin theta minus Fk, where F is the applied force, net force. So F is equal to mg sin theta minus Fk, where Fk is the kinetic friction force. As we know that F is equal to ma mg sin theta, and the place of Fk we place mu kr, and R is equal to mg cos theta. So at the place of Fk we directly put mu k mg cos theta. At the place of Fk we directly put mu k mg cos theta. As F is equal to ma is equal to mg is common thing, so sin theta minus mu k cos theta. As mg is common, so inside the bracket we put sin theta minus mu k cos theta. The m is cancelled each other, both sides of m is cancelled each other because m is common, so m is cancelled each other. At the result of it, the acceleration A is equal to g sin theta minus mu k cos theta. It is the required expression. Now, laws of rolling friction. Laws of rolling friction. The first law states the rolling friction is directly proportional to the normal reaction. Now the first law states the rolling friction is directly proportional to the normal reaction. The first law states the rolling friction is directly proportional to the normal reaction. So Fr represents the rolling friction is directly proportional to R, where R is normal reaction. And the second law states the rolling friction is inversely proportional to the radius of the rolling cylinder or wheel. The rolling friction is inversely proportional to the radius of the rolling cylinder or wheel. So Fr is inversely proportional to 1 by R. Combining both things, so Fr is directly proportional to R or inversely proportional to small r, where small r is the radius of rolling cylinder or wheel, or Fr is equal to mu r by r, where mu r is called coefficient of rolling friction, rolling friction. So the two laws of rolling friction, the first law states the rolling friction is directly proportional to the normal reaction. The rolling friction is directly proportional to the normal reaction, and the second law states rolling friction is inversely proportional to the radius of rolling cylinder. Rolling friction is inversely proportional to the radius of the rolling cylinder or wheel. So Fr is inversely proportional to 1 by R, and where 1 by R, small r represents the radius of rolling cylinder and the capital R represents the normal reaction. Combining both the things, Fr is directly proportional to R by R, or Fr is equal to mu r by R, where mu r is called coefficient of rolling friction. Now the main advantage, the first advantage, it is due to friction between the ground and the feet, we are able to walk. Now it is due to friction between the ground and the feet that we are able to walk. And the second thing is the brakes of a vehicle cannot work without friction. The brakes of the vehicle cannot work without friction. The first advantage is due to friction between the ground and the feet, then we are able to walk. And the second is the brakes of a vehicle cannot work without friction. Now what is the method of reducing friction? By polishing. If you polished the surface, then the force it gets smooth and the force of friction get reduced. So by polishing we reducing friction. Now after lubrication, by use of oil or grease or anything, we reduce the frictional force, and by streamlining we reduce the friction force. So method of reducing the friction, the first is by polishing, by lubrication, by streamlining. And in the next session we discuss about level curve road, banking of road and bending of cyclist. Till then, goodbye, have a nice day. Thank you.